Well, this section here that we're going to be talking about is relative extrema. And when we talk about extrema, we're basically talking about the minimum and the maximum, the smallest and the largest value in a set. And relative means relative to this particular area. The interval that we're going to be working on here is actually just the open interval from between negative infinity and positive infinity. So we're interested in just probably going to be in this particular part, this particular graph here. So here's our function x squared plus 2x minus 1, and we're going to want to find where this function, I'm going to go ahead and throw in something extra here, where the function's increasing and decreasing, and the point of which it's either a minimum or a maximum, or maybe there's more than one point. There could be a min or a max. As you can see in this graph right here, the minimum is occurring, here's my coordinates up here, and I'm just kind of approximating it, but it's somewhere in this area right here. It's going to be probably x is equal to -1, I'm guessing, and y is going to be equal to, it looks like possibly -2. Alright, as you can see here, reading this graph from left to right, as you can see the little blue dot here, well, the graph is decreasing. The y values are decreasing until we get to the minimum here, and then the graph starts increasing. Okay, so, and we're between negative infinity and positive infinity, so the graph is decreasing from negative infinity, okay, up to -1, and then the graph starts increasing from -1 to positive infinity, and we're talking about values on the x-axis here when we talk about that. Let's see, what else can I throw in? The first thing we're going to do to this function is we're going to take the derivative, and we're going to find what are known as its critical values or critical numbers. We're going to find the critical numbers. Okay, a derivative could possibly exist at these critical numbers, or the derivative may not exist at the critical numbers. Anyway, I'm not going to go into stating any theorems and so forth. The idea here is we want to be able to work some problems out, right? Every once in a while I'll actually state a theorem or two. Well, let's get started on this one. Alright, so let's write it out here. I hate that when that happens. Forget that every time. My canvas is in layers, and that's the reason that happens. But anyway, we don't talk about all that. So we have f of x equal to x squared plus 2x minus 1. And remember, we're on the interval between negative infinity and positive infinity. Okay, this is the interval we're on. First thing I'm going to do is I'm going to take the derivative of this. So hopefully you guys know how to take the derivative of something as easy as this one here, this polynomial. And then what we're going to do is find the critical numbers. We're going to take the derivative, set it equal to 0, and solve for x. So the solution in this particular one is -1, right? So x is -1. If you plug -1 directly in right here, you get 2 times -1 is -2, and -2 plus 2 is 0, right? So we're looking for the solutions to this equation. And these are, and I'm just going to label this as the critical number Cn. So then what we want to do is we want to draw a number line. Okay, so I want to draw a number line, and on the number line I'm going to label my critical number, and I'm going to put it right here. And then what we're going to want to do is we're going to want to pick a point to the left of -1, and I'm going to pick -2, and then we want to pick a point to the right of -1, and I'm going to always choose 0 if I can. These are known as our test points, and they're going to tell us whether the function is increasing or decreasing, or if the derivative is negative or positive, and then that's going to give us an idea of what this guy is right here, if this is going to be a min or a max is located at this point. Now what we want to do is we want to plug in our test points into the derivative, because the derivative tells the slope of the tangent line at that particular point, right, if it's going to be negative or positive.